All right, let's work through the homework. All right, so I want to find the zeros of the function, basically the x-intercepts, and write it in intercept form. All these will be like this. So right away I see that this is the difference of squares. This is from my list. (64) is really 8 squared. So I can rewrite this as x minus 8, x plus 8. So the roots, or actually this is it. We're not looking for the roots. This is the intercept form right here. That's the answer. That was number 5 on the homework. Starting with 5. All right, number 6. Now we're just going to factor this. All right, I need to come up with two numbers that multiply to make 45, negative 45, and add up to 12. So 3 and 15, but this is negative, so one of them needs to be negative. Which one? I gotta look here. Because this is negative, the big one needs to be negative. So this is gonna be plus 3, minus 15. That's the intercept form for number 6. All right, moving right along, number 7. So this is 6. X squared minus 22x minus 121. Just kidding. Y equals x squared plus 22x plus 121. All right, this is nice. Again, I'm going to factor this. 121. 121 is a perfect square, 11 times 11. And it just so happens 11 plus 11 is 22. So this is going to be x plus 11, x plus 11. All right, that's the intercept form for number 7. All right, so get number 8. Plus 6x minus 55. All right, number 8. All right, again, I'm factoring. This is a 1, so I can factor it like normal. Negative 55. (11 and 5). But it's negative. I look here, this is positive. So that means the small one needs to be negative. All right, because negative 5 times 11 is negative 55. 11 plus negative 5 gives me 6. This is going to be x plus 11, x minus 5. So all of these are going to be pretty repetitive factoring, right? You're always trying to find what two numbers multiply to make this, but add up to that. And I do this when the coefficient in front of the x squared is 1. Let's look at number 9. Factor the expression. If it cannot be factored, say so. Okay, well, see what happens. All right. Number 9. Oh, these get harder. Okay, so we're just factoring it, we're not solving it. Slide and divide method. Multiply these two numbers together. So x squared minus 2x. 8 times 5 is 40. Carry the 4. 8, 9, 10, 11, 12. Okay. Two numbers multiply to make 120 that add up to -2. So I know that the big one needs to be negative, and they've got to be fairly close to each other. So 12 and 10, right? 12 and 10 make -120. -12 and -10 make -2. There's going to be x minus 12. X plus 10. But because I multiplied this in, I have to divide this guy out. So, all right, let's see. We'll reduce, if possible. It is possible. Factors of 3, multiples of 3. So 3 goes into 12 4 times. 3 goes into that 5. Here, we'll use 5. So 2/3. All right, these numbers swing up. So it's going to be 5x minus 4, 3x plus 2. Do a quick little check. 5 times 3 is 15x squared. All right. So that's the factored form. Number 10. (14m squared plus m minus 3). I'm going to multiply this over. So this will be m squared plus m. 3 times 4 is 12. Carry the 1, 3, 4. Negative. All right, so -42. Multiples of this that add up to 1. So 6 and 7, that's what jumps out at me right away. One of them needs to be negative, so I look here, it needs to be the small one, because that's positive. So this is going to be m minus 6, m plus 7. We have to divide the 14 back out. So both of these are even. So m is going to be divided by 2. Here I'm going to divide by 7. All right, so I'm going to move the 7 up. So 7m minus 3. I'm going to move the 2 up. So this is 2m plus 1. Not bad. Not bad at all. All right. Number 11. Five x squared plus 14x minus 3. All right. So all these are going to be pretty much the same. Multiply these two numbers. X squared plus 14x minus 15. Negative 15, multiples that make negative 15 that add up to 14. That's 15 and 1. Now take that back. It's not 15 and 1. Yeah, it is. It's 15 and 1. So 1 times 15 is 15. But I want it to be negative. One of them needs to be negative. So I look here, it's a small one. It's a small one because that's positive. You're going to see a pattern here. So this means x minus 1. X plus 15. Because we divided by 5, I have to divide the 5 out. So this is going to move up. This is going to reduce to 3. So 5x minus 1 times, or 5x minus 1, this will be x plus 3. That looks right. That was 11. All right, number 12. Four r squared minus 25. Well, we have two terms, so I always want to look forward to see if the difference of two squares will work. And it does. It does, right? This is in our list. So this is really 5 squared, r squared. 4 is really 2 squared. All right, I can pull out the exponent. Now, difference of squares says a squared minus b squared. I can do, right, it says a squared minus b squared. Right, this is the property that I'm applying, right? This is my a squared minus 5 squared. I can do that. So 2r minus 5, 2r plus 5. Applying the difference of squares. That's it. Number 12, that's it. All right. Thirteen. Okay. 16s squared plus 8s plus 1. Again, a term is not 1. So So I'm multiplying it here, which is nice because that's a 1. So s squared plus 8s plus 16. 1 times 16 is 16. Two numbers that multiply to make 16 that add up to 8. 4. They're all positive, so everything's positive. So this is going to be s plus 4, s plus 4. Because I multiplied that in, I got to divide it up. So it's 1 over 4. 4 is here cancels, 1 over 4. So this is going to be, right, this comes up. This comes up. So 4s plus 1 times 4s plus 1. Some might argue that this is 4s plus 1 squared because there's 2 of them. Either one of those answers are acceptable in my opinion. Okay, 14. All right, 64 w squared plus 144w plus 81. All right, the thing that jumps out at me is that they're all perfect squares. So 64 is 8 squared, w squared, 12 squared, plus 9 squared. All right, and we're going to apply the trinomial, the perfect square property for trinomials. They're both positive. So this is going to be, so we can rewrite this as, that's my a value. My b value, so 2 times a times b, so 2 times a times b actually bring that back to 144. That 144 would be more useful. That's actually better. All right, so then this would be 9 squared. So does this equal 144? That's the question. So 8 times 9 is 72. 72 times 2. Yeah, it's 144W. All right, so we've confirmed that this all fits the trinomial perfect square property. So then I can say it's going to be a plus b squared. So a and then b. Right, because the property says a squared plus 2ab plus b squared. If that's the case, then we can say that. If this is the case. And in fact, this is the case. It's exactly what this fits. Right? This is my A. 2AB comes out to 144W. And then 9 squared. So, it's the answer. Number 14. All right. Number 15. (25t squared minus 30t plus 9. Same thing, right? This is a perfect square and that's a perfect square. So 5 squared t squared minus 30t plus 3 squared. The only difference is that we have a minus here, so that means minus will be in our answer. 5t squared, and then 2 times a times b. So does this equal that? That's what we want to verify. So 2 times 3 is 6, times 5 is 30. So yes. So this is going to be 5t minus 3 squared. Again, the property for this one, a squared 2ab minus b squared, a minus b squared. So this is the property that we're applying. Actually, that's the property we're applying. It's a plus. So minus, plus, everything fits, it all lines up. All right. (16). 12x squared minus 4x minus 40. No perfect squares here, but they're all even numbers. I could pull a 2 out. Greatest common factor would be a 4. Let's pull a 4 out. So if I factor out a 4, what's left behind? 3x 10. I like where this is going. All right, so I'm going to multiply, because this isn't 1, I want this to be 1 for this to work. So this is going to be x squared minus x minus 30. Two numbers that make 30, that add up to -1, 5 and 6. One of them has to be negative. It's going to be the big one. So 4, right, this is the most forgotten about piece. So 4 where was I at? 4x squared (5 and 6). All right, lose my train of thought. X plus 5, x minus 6, right? Because these numbers just drop right in. Now we have to divide out of 3. So this is going to be 2. The 3 is going to move up. So final answer, 4x, 3x, plus 5, x, minus 2. Four, 3x plus 5, x minus 2. 17. (32x squared minus 2). All right, 32x squared minus 2. It's a binomial, so right away I want to start thinking about difference of squares. Well, this isn't a perfect square, but they're both even, so let's pull out a 2. So it's going to be 16, that's a perfect square. 1, 1's a perfect square. We're factoring out a 2 from everything. That's what's happening. Whatever number I pull out, that's the number that goes in front. All right, this is a perfect square, that's a perfect square. I'm gonna pull out the exponent. And now we have our A and our B. So this is going to be 2A minus B, A plus B. Two, 4x minus 1, 4x plus 1. So the conjugates, right? Perfect squares, difference of squares, use the conjugates. The conjugate of these guys. All right, that was 17. $18. $12x squared minus 36x plus 27. Are there perfect squares? 12 and 27. No, but they're all divisible by 3. So let's pull out a 3. So 12 divided by 3 is 4. 36 divided by 3, 12. 27 divided by 3 is 9. All right, so here, we're at a fork in the road, right? Fork in the road. We can either slide and divide and make 36, or we can do the trinomial perfect square property. What do you think? Let's go with, well, let's see. Let's do some mental math. 36, two numbers that multiply make 36, they add up to 12. 9 and 4. That don't add up to 12 though. All right, I'm gonna stop thinking about it. Let's just go with the perfect square method. So this will be 2 squared minus 12x plus 3 squared. All right, I'm gonna factor out the square. So that's my A value. So this is gonna be 2 times A times B. 2 times 2 is 4, times 3 is 12. All right, so then 3, right, because that's coming along for the ride. And now I just do A minus B, right, because there's a minus and there's a plus. So there's a minus in here because of that minus. So A minus B squared. That one wasn't bad. I mean, we could have done it the other way, but in my head, and you know, it's pretty late, so let's go with what works. $19. 21x squared 77x minus 28. All right, this is where you have to have some sort of number sense, right? 3 numbers. What's common to all 3? 7 jumps out at me. Could it possibly be more? Maybe. So let's pull out a 7. If I pull out a 7, 3 x squared 11. 7 times 4 is 28, so 4. All right, no perfect squares, so we're forced So x squared minus 11 minus 12. Right, 3 times negative 4 is negative 12. Two numbers that make negative 12 that add up to negative 11. What we got? 3 and 4. 12 and 1. So negative 12. 1 and 12. It's negative. We look here, this is negative, so the big one needs to be negative. So this is going to be x plus 1, x minus 12. I need to divide the 3 back out. So this is going to be 4. So we have, this isn't clean, that moves up. 7's got to come down. Can't forget about the 7. So 7, 3x plus 1, x minus 4. All right. It's going quick, so you can always pause the video and go back and listen to what I said, but it's pretty straightforward. It's the same process every time. We're more than halfway through, so that's good. All right, we're on 20. My marker's about to run out. All right, what's 20 say? 8x squared plus 28 minus 60. 8x squared plus 28, x minus 60. A 4? Is 60 divisible by 4? 4 goes into 6. Well, it's divisible by 2. It's 30. 2 again would be 50. So yeah, it's divisible by 4. So let's pull out a 4. So this is going to be 4 x squared 7 x 15 and no perfect squares, so slide and divide method. X squared plus 7 minus 30. So two numbers that multiply to make 30 that add up to 7. All right, so don't even think about it. Let's just start powering our way through. So 1 and 30, 2 and 15, 3 and 10. That's the 1. 3 and 10. 3 and 10 can make a 7. But this needs to be negative. So one of them has to be negative. It's the small one. So x minus 3, x plus 10. But since we did the method, I got to divide a 2 out. And then we can't forget about the 4. So this is going to be 5. The 2 is going to come up. So 4, 2x, right, because the 2 goes up, minus 3, x plus 5. That one wasn't bad. That one was actually kind of fun. All right, 21. All right, so solve the equation. So here we have some kind of polynomial that equals 0, or some kind of quadratic rather. All right. (21) 16x squared minus 1. All right, so I want to, so there's a couple ways you can do this. There's a single variable. I can move the 1 over, divide by 16, take a square root. I know it's going to come out to 1 over 4. But let's see if we can do it by factoring. So this is 4 squared, x squared, 1 squared. All right. Difference of squares. I'm always looking out for it. Difference of squares. So this means 4x minus 1, 4x plus 1 is equal to 0. So I got to set them each equal to 0. So this is 4x minus 1 equals 0. 4x plus 1 is equal to 0. So 4x plus 1 divided by 4. All right, so this is going to be x is equal to 1/4, positive. And this is -1, so 4x minus 1 divided by 4. So x is equal to -1/4. Right, what I was saying was, if we wanted to, we could add 1, divide by 16, take a square root. Square root of 1 is 1, square root of 16 is 4. So x is equal to plus or minus 1/4. That way it's way more efficient. But since we were talking about factoring, let's just do it this way. All right. (22). 14x squared minus 21x equals 0. (14x squared minus 21x equals 0. All right. Greatest common factor. So number-wise, I can pull out a 7. Variable-wise, I can pull out an x. So each of those divisible by 7, there's an x in both. So 7x. So 2x would be left over if I divide that out. And then 3. So quick dummy check, put it back in. This times this gives me that. 7x times -3 gives me that. So we're good. Set each of these equal to 0. This one's nice. 7 times what is 0? 0. Here we have 2x is equal to 3, right? Because I'm adding 3 to both sides. This would be divisible by 2, or divide by 2. So x is equal to 3/2. So 0 or 3/2. That was 22. 23. (4x squared minus 20x plus 25). 4x squared minus 20x plus 25. All right. Right away I see perfect squares. So 2 squared x squared minus, so I know this is going to be 5 squared. That's my b value. That's my a value. Actually, my a value, if I pull out or if I factor out the exponent now, it's going to be like this. So this is my a value. So 2 times a times b. So 2 times a times b. Two times 2 is 4, times 5 is 20, so we're good. All right, this is minus. So it's going to be minus in my answer. All right, this is the minus property. All right, so A, B. That one's not bad. It's so much easier when you can recognize the perfect squares. All right, 24. 15x squared plus 7x minus 2. All right, 15x squared plus 7x minus 2. No perfect square, so I'm gonna have to multiply the 15 over. Marker's dying. So this is going to be negative 30. Two numbers that make negative 30. Multiply make negative 30, add it to 7. So 1 and 30, 2 and 15, 3 and 10. Those are it. 3 and 10 make 7 for sure. This needs to be negative. So one of them needs to be negative. Which one? I look here, it's positive, so the small one. X minus 3, x plus 10. Now I have to remember to divide the 15 out. Three goes into 3 once. 3 goes into 15 5 times. Here I'll use 5, goes into 10 twice. 5 goes into 15 3 times. Again, it's not clean, so these numbers move up. Nothing was in front, so this is going to be 5x minus 1, 3x plus 2. Equals 0. Oh my goodness. Now I'm questioning myself if I did equals 0 in the last problem. I don't think I did. All right. So 5x minus 1 is equal to 0. 3x plus 2 is equal to 0. So this is going to be plus 1 divided by 5. This is going to be minus 2 divided by 3. Can we still see the marker? Yeah, we can. All right. All right, those are our solutions. $25. 36, 96, 15. 36, 96, 15. Okay, for sure I can pull out a 3. So this is going to be 12, 3, 2, 5. All right, nothing can be pulled out here, but stick to the script. All right, so this is going to be x squared, 32x, plus 60. All right, can we figure out at a glance? 60, 32, 30 times 2. Hey, 30 times 2. So 60, right? This would be 30 times 2. So they're all positive. X plus 30, x plus 2 I have to divide a 12 out. So this is gonna be, what is this? 3 can go into both of these. 6 can go into both of those. So 6 would be 2, 6 would be 5, 1, 6. All right, these numbers are gonna move up. And we can't forget about the 3. So 3 times 2x plus 5 times 6x plus 1 equals 0. Right, oh my goodness, equals 0, not complete. All right, equals 0, because we're solving. So set each of those terms equal to 0. I'm not necessarily worried about the 3, because once one of these is 0, it's gonna cancel that 3 out. So I'm not worried about the 3 right now. So it's gonna be 2x plus 5 equals 0. 6x plus 1 is equal to 0. So this is going to be minus 5 divided by 2. I'm just doing that in my head. I know I'm subtracting 5. I know I'm dividing by 2. So negative 5 divided by 2. Negative 1 divided by 6. All right, 25, 26. All right, we'll only go up to 28. All right, so 26, 24, okay, it's a long one. Twenty-six is 24 x squared plus 8x plus 2 equals 5 minus 6x. All right. I'm going to move everything to one side. One side of what? The equation. All right, so plus 6x plus 6x. Combining like terms. 8, 9, 10, 11, 12, 13, 14. So 14 minus 5, negative 3 is equal to 0. Okay, there's no perfect square situation. We're gonna have to multiply. Can we pull out a 3? No, because it's not divisible by 14. 14 isn't divisible by 3. Okay, let's do it. So this is gonna be x squared plus 14. So just so you're following, I'm multiplying these two. I gotta write slower because the marker's running out. This is gonna be negative. So 25 times 3 would be 75, but minus 3 would be 72. Equals 0. Okay. What numbers multiply to make 72? 9 and 8. Does that work though? No, 9 and 8 don't make 14. And it's negative 72. So that one doesn't work. 10, 11, 12, 72, so 60, 72. So 12 and 6, 12, 24, 36, 48, 60, 72, yeah. Can that make 14? It can because it's negative. So one of them has to be negative, the small one. What? That's not right. Not right at all. So negative 6. Negative 6 times 12 is definitely negative 72. But it doesn't add up. All right, so let's go the other direction. What else we got? 9, 11, 12, 13, 14, no, 16? 16 maybe? 16, 32 times 2, 32 times 4 is 64. No, 16 doesn't work. 9, 8. Let's go down 6. So let's think about this for a moment. 1 is 72. 2 and 36. 3. Will 3 go into it? 3 goes into 7 twice. 3 goes into 7 twice, and then 6. Is that true? Yeah, but we can't make 14. That's the bad news. So then, about 4. Well, 4 goes into 7 once. 4 goes into 7 once. Then 8. Aha, finally. All right, I can definitely make a 14 out of this. So it's gonna be the smaller one. It's the small one. So it's not bad. It's not bad at all. All right. X minus 4, x plus 18 equals 0. We got to divide a 24 out. So this is going to be, so this is 4 goes into 4 once. Here's 6. I know that 6 is going to come up. And so it's a 1. So 1. Here we have 18 and 24. They're both even. So if I do 2, this will be 9. 2 goes into 12. But then 3. All right, 3/4. So the 4 is going to come up. So 4x plus 3. That one almost got us. All right. Make sure I don't forget anything. Equals 0. Oh my goodness. We're solving it. So I got to set each of them equal to 0. So 6x minus 1 equals 0. 4x plus 3 equals 0. All right, I'm going to add the 1 and then divide by 6. I'm going to subtract the 3, divide by 4. Okay. That's definitely a tougher one. Okay, 26, 27, 28. What time is it? All right, I can knock these last two out. 27.13 x squared plus 21 x equals negative 5x squared plus 22. All right, I'm gonna move everything to one side. (13 and 5 is 18. Plus 21x minus 22 from both sides. So minus 22 equals 0. All right, so this one's gonna get us for sure. There's no perfect square. Can't factor anything out because 21 and 22 are like next to each other. You know, on a number line, they're next to each other. So nothing will come out of those two. There's nothing we can do. All right. Okay, so 22 times 18, 16, 17, 2, 6, 9, 396. Oh my goodness. Okay. All right. So let's see. (396) 2, 4, 's divisible by 7. 739. 6. 36. 6. 36. 6 and 66. Okay, so it's bigger than 6. 7, 8, 9, 9. 9 goes into 39 4 times. It's 36. 9 and 44. Right, 9 and 44. Oh man, my marker's dying. Marker's dying. Time to go home. Nine. 36, 39. So 9 and 44, but that doesn't make 21. And even if we were to add these together, so we still have a ways to go actually. That's what that means. 12. 12 would work. 12 would work. Let's go. 12 and 33. All right. So 3, 96, 12, 12 and 33. Because when I add them together, oh no, wait, dang it, I thought I was subtracting them. Oh, yes. Which means minus. Okay, it's getting better. So one of them needs to be negative. I look here, the smaller one needs to be negative, and then that'll give us 21. Let's go. All right, so this is gonna be x minus 12, x plus 33. Okay, we had multiplied this in, so we need to divide that back out. Okay, this is divisible by 6. 6 goes in 12 twice. 6 goes in 18 3 times. 3, I can use 3 here. That's 11. 3 goes into 18 6 times. All right, both these numbers are going to go up. So this is going to be anything. Am I missing anything? No. All right, so x, 3x minus 2, 6x plus 11 equals 0. Can't forget about that. Does the blue show up? It does. All right. So set each of these equal to 0. 3x minus 2. So I'm going to add 2 and divide by 3. Then 6x plus 11 equals 0. I'm going to subtract 11, divide by 6. That one was a nail biter. It was a nail biter. All right, last one. And then I've got the rest. 28. All right, 28. X plus 8 squared (16) minus x squared plus 9. All right, I'm gonna move everything to one side. That's the idea. But I want to expand out the left side. I want to expand this out. It's a binomial squared. So I'm going to do what the perfect square trinomial teaches us, right? I'm going to a squared, so this times this, right? X times x. 8 times 8 is 64. And then 2 times x times 8. So it's going to be 2 times 8 is 16 times x. All right. So again, binomial squared, I do x times x, 8 times 8, 2 times x times 8 equals 16 minus x squared plus 9x. All right, so does it matter which way we go? I don't think it does. What's going to happen here? Make sure I wrote the problem down right. X plus 8 squared, 16 minus x squared plus 9. Okay. Add x squared, add x squared. So this is going to be 2x squared minus 16. So minus 16. So it's 54. 54 minus 6. 48. I'm going to put the 48 over here. And then minus 9x. So it's going to be 7x. 7x. Is that true? 16 minus 9 is 7. That is. Equals 0. Equals 0. All right. We're cooking. 7's not an even number. It's messing things up. All right. I'm going to multiply the 2. All right. X squared, 7x. 48 times 2 is 80 plus 16, 96. Equals 0. Okay, let's think about this for a moment. Numbers that multiply to make 96 that add up to 7. So the thing that jumps out at me first is 3. So what is this? 3 goes into 9 3 times. 3 goes into 6 twice. Right? 3 times 32. Okay. Well, I can't make 7 out of that. So let's keep going. 4, 5, 6. The 6 go into 9 once. 36. 36 left over, so it's going to be 6. 6 and 16. Can I make a 7? No, but we're getting close. 7, 8. Let's try 8. So 8. 8 goes into 9 once. 1 left over. 16 twice. It's not working either. Okay. What's crazy is that we're getting really close. So what about 9? Will 9 work? No, it won't work. 10, 11, and then 12. 12 would work, but then it's 8. So it's like, I don't know. I don't know. Is this one that won't be factored? Let me just think for a moment. Let's check our math. Subtracted 16, so this is 54, right? Minus 10 is 54. 54 minus 6. 54 minus 6 is 48. Subtracted 9. 16 minus 9 is definitely 7. 2, 2. So x times x is x squared. 64. 2 times 8 is 16. All right, it works out. I mean, it's not working out, but it looks correct thus far. All right, so at a glance, I don't think it's gonna work, but let me just check my answer. Or not my answer, I don't think it's gonna work. So minus b squared minus 4ac. Aha. Okay. All over 2a. Okay, so technically, you can always fall back on the quadratic formula just to check yourself, or at least that's what I'm doing. We haven't talked about this yet in class, but all right. this is going to come out to a negative number, right? 4 times 96 is a big number. It's like 300 something. 49 minus a big number is definitely going to be negative, so the inside is going to be negative. So as of this moment, this has no real solution. So no real solution. Right, no real solution. Question is, would you have been able to figure that out? Yeah, because it's shifted up. This is shifted up. All right, can't be factored, at least right now. All right, so that's 5 through 28. I did almost all of it. So just work the rest out. Good luck.